In this class, we are going to consider solve examples on simple plane electromagnetic waves. Let's start with the first example. The first example says, for a non-sinusoidal wave, suppose the electric field is given by 100 volts per meter. If the electric field is not given by the unit volt per meter, you could see newtons per coulomb. So I had to repeat the same value for both units so that one would not be confused. Okay, so let me take it again. For a non-sinusoidal wave, suppose the electric field is given by 100 volts per meter or 100 newton per coulomb. Find the value of the magnetic field B. Take C as the speed of light in a vacuum. For a problem like this, you can see that electric field is given. Magnetic field, we are to solve for the magnetic field, and then the speed of light is being considered. Those are three quantities, so we are going to use this expression E equals to CB. E equals to CB, equation 1. So the E there represents electric field and the B there represents magnetic field. Then C, the speed of light, where E is electric field, or you can call it electric field intensity in volts per meter or newtons per coulomb. C is the speed of light and it is a constant. B is the magnetic field strength or magnetic flux. The SI unit is in Tesla. Solution. Since we were asked to solve for B, I decided to write B equation sign. So that's the unknown quantity, meaning that in equation 1, we are going to make B the subject. And when we do that, we substitute the given value for E and C, and we obtain our answer. So E is 100 volts per meter. C is the speed of light, and the speed of light is given by 3.0 times 10 to the power 8 meters per second, making B the subject in equation 1. Then we get B equals to E over C, substituting the value for E into E and C into C, just like we have here. When you simplify that with your calculator, or you strike the values, the zeros, you will obtain the final answer, B, the magnetic field in Tesla. You can as well do that to confirm it. Please, I want you to encourage us. Do us a favor by clicking on the subscribe button if you have not yet done that. Introduce us to a friend. That would really be wonderful. Let's continue to the next example. Example 2. Note the expressions. Wave number K equals to 2 pi over lambda. That's equation 1, expression for wave number. Angular velocity omega equals to ck, where c is the speed of light and then k is the wave number. These are the expressions we are going to use in solving this very problem, where k is the wave number, in radians per meter. Omega is angular velocity in radians per second. Lambda is the wavelength in meter. C is the speed of light or the speed of electromagnetic wave in a vacuum in meters per second. Please, I would also like to emphasize on the SI unit of these quantities, like the SI unit of the wave number here, radians per meter, the SI unit of the angular velocity, radians per second. They are very important, even that of wavelength and velocity. Let's take this question. Estimate the wave number and the angular velocity of an electromagnetic wave if the wavelength is 10.6 times 10 to the power minus 6 meter, assuming pi is given by 3.142. Okay, so I have written the answer we will get below here in green color. That one is not part of the equation. That's the solution, to the problem. So by the time we solve it, we now compare whether it's the same. You can as well do that. That was why I had to start with the expression. You can as well do that before you wait for me to solve as well. Alright, so in the given question, we are asked to find the wave number. The expression for the wave number is given in equation 1, and the second one says angular velocity, and equation 2 gives us the expression for angular velocity. Let's get started. Solution. Wave number is k. Equation sign. The wavelength is given 10.6 times 10 to the power minus 6 meters. If we apply equation 1, k equals to 2 pi over lambda, we substitute the value of pi into where we have pi, and then the wavelength, the value of the wavelength into lambda. When we simplify that, we will get 592,830 radians per meter. You now compare this with what we have here in our answer. The answer was written in standard form, but here was in ordinary form. It's still the same thing. You should be able to convert from ordinary numbers to standard form and vice versa. Alright, so let's proceed. Let's solve for the angular velocity using this expression omega equals to ck. We substitute the value of the speed of light into c, and then the k for the wave number. Whatever it gives us would be our answer. I would like you to do that and compare it with the solution we have here, whether it is the same. And I believe you can still remember the SI unit. Let's move to the next slide. Example 3. Look at this classwork. The question says, assuming a power line has a frequency of 60 Hz, if c is the speed of light in a vacuum, estimate the wavelength of the power line. Assuming a power line has a frequency, so frequency is given in Hertz, and we know about the speed of light. We are asked to estimate the wavelength. This is a classwork, meaning you are the one to solve it. But I will guide you. Use the expression C equals to F lambda, but you do it by yourself. C equals to F lambda. C would be for the speed of light. The frequency is given in hertz, so we are to find the wavelength. I hope you can do that. Let me give you hints. Make the wavelength the subject of the expression. It's just a matter of one step. I just want you to try this. Substitute the given quantities into the expression, and you can as well message me directly. And message me if you were able to do that. You check your answer. If it will give you 5,000 kilometers. If you are able to arrive at 5,000 kilometers, then you clap for yourself. I will give you time to do that while I wait. Okay, let's see what the solution is. This is what I ask you to do. When you make lambda the subject, this is how the new expression would be. Substitute the values. You will see 6 zeros, 5 0 0 0 0 6 zeros. Remember that kilo is the same thing as 1,000, so it's not wrong if we decide to write the answer this way. Don't accuse yourself of being wrong. It's still correct. Okay. Speed of electromagnetic waves. The speed of electromagnetic wave in a vacuum can be deduced using the expression C equals to 1 over the permittivity, or the square root of the permittivity and permeability. Where C is the speed of electromagnetic wave in a vacuum, take permittivity of free space. This is a constant to be 8.85 times 10 to the power minus 12 Coulomb square per newtons per meter square. Okay. Then permeability of free space is 4 pi times 10 to the power minus 7. Also note the constant. If we substitute these values into equation 3, it gives us the speed of light. Substitute the constant and check the solution. I would like you to try that. Look at this expression in equation 2a, b, okay, and 2b as well, 2a and 2b. Equation 3 is obtained where b is equal to E. Of course, we know that epsilon naught there is permittivity of free space and permeability of free space. Then we have magnetic field B, we have electric field E. We also have C for the speed of light and V for the speed of light in a medium, where C is the speed of electromagnetic wave in vacuum, V is the speed of electromagnetic wave in a medium, and all of that. So just note that expression. It is from equation 2 2a that we deduce the expression for equation 3, which we use to find the speed of light in a vacuum. So at a point where B and E has the same expression, we will always derive equation 3, and that's how we got that. Okay, let's look at equation 4 here, where S is energy density per unit area. S is the energy density per unit area. E is the electric field, and B is a magnetic field. And then mu naught here is the permeability of free space. So the SI unit of the density, energy density, is written below: watt per meter square, or volt ampere per meter square. Let's proceed. Assignment. I would like you to do this assignment. When you do the assignment, you inform me. The first one says, for a non-sinusoidal wave, suppose the magnetic field is given by 3.33 times 10 to the power minus 7 Tesla. Find the value of the electric field. Take C as the speed of light in the vacuum, or in a vacuum. We have already solved that. I would just want to see if you understood what we did today. Okay. This one says, how is the equation below called, and list the quantities involved. So this is the equation. What is the name of this equation? And the quantities you are seeing in this equation, what are their names? They just listed, that's all. This one says, one of the following is the SI unit of wave number. One of the following is the SI unit of wave number. We have treated that, so I would like you to answer that for yourself. One of the following is the SI unit of angular velocity. One of the following is the SI unit of angular velocity. Solve that for yourself. Estimate the wave number k and the angular velocity omega of an electromagnetic wave if the wavelength is 10.6 times 10 to the power minus 6. Assuming pi to be 3.142. Okay. This one says, estimate the energy density per unit area. It's supposed to be per unit area. Please take note. This point here, this is area. Estimate the energy density per unit area, assuming electric field is 100 volts per meter and magnetic field is 3.33 times 10 to the power minus 7 Tesla. Take the permeability of free space to be 4 pi times 10 to the power minus 7. Okay, so that's how far we can go for today's lectures. Please, I would like you to encourage us. You are watching Supreme Online Lectures. I want to say thank you very much for watching our channel today, and I would still love to see you another day. Encourage us by clicking on the subscribe button if you are yet to do that. You can as well follow us on Facebook. That's why we had to put the YouTube link, and that of Facebook is still the same the same link. So thank you and have a wonderful day. Bye.